All right, let's graph a generalized cotangent wave. So this cotangent has possibly everything we could do to it. It has some vertical shifting, it definitely has some phase shifting, it has a change in the period, it has a change in the way it behaves, amplitude-ish information, everything I could think of to mess this cotangent up. But keep in mind what a cotangent, the basis of it is. So the period is pi. Normally, the asymptote at the origin, and then you go over a period, and another asymptote. Halfway in between, it's sitting on the x-axis, it's baseline. Then halfway over, this would be 3 pi fourths, it's down 1, or at pi fourths, it's up 1. And then we sketch this decreasing function called the cotangent. That's our normal information. That's what we're going to be adjusting to figure out where this thing is in its graph. So let's work through. Let's do the period. The period is normally pi. Divide that by the coefficient of omega, in this case the 2, and this one's period pi halves. The phase shift. The phase shift is whatever makes the inside of the function equal to 0. You could factor to see it a little more clearly, or you could just set it equal to 0. I would leave that up to you. I'll show you both. The factoring, if I factor out a 2, I'm dividing by 2. This would be this. And then I can see that negative 3 pi fourths is the phase shift. But again, you could also just set the inside equal to 0 and solve, and you would get x equals negative 3 pi fourths as well. Regardless of how you do it, either by factoring and just what makes that 0, or by setting it equal to 0 and solving, we get the phase shift of negative 3 pi fourths. Okay, now in comparing our pi halves, the period of pi halves, we need to know half of that, and then half of that as well. So I like to take the period and divide it by 4 so that I know how to set up my tick marks. So in comparing the phase shift, pi fourths and pi eighths, the common denominator of that is pi eighths. So I'm going to set up these tick marks as pi eighths. I don't know exactly how many I need, so I'm going to do a bunch to the right and a few to the left. So this is pi eighths, 2 pi eighths, which is pi fourths, etc. Okay. Next up. Normally, I think I'm going to need a few more. So normally, right at the origin is an asymptote. But we're shifted left 3 pi fourths. In terms of our tick marks, that's 6 to the left. I only have 4 of them. How do I want to adjust this? Let's just make the tick marks twice as small. Now I'll have way too many tick marks, but all of these tick marks, this is pi eighths. So our asymptote is normally at the origin for a cotangent, but in this case it's 6 tick marks to the left. So 1, 2, 3, 4, 5, 6. There we go. That's our asymptote. That's our first asymptote. And now the period is pi halves, which in terms of our tick marks is 4 pi eighths. Our period is 4 tick marks. So if we go right 4 tick marks, we have another asymptote. And right 4 tick marks, we have another asymptote. Continuing on, 4 tick marks, asymptote, etc., etc., etc. Now I'm ready to look at where the point starts, and I see that I didn't work out the vertical shift. I didn't need it until now. The constant term, plus 1. So, in between the asymptotes, normally the cosine's at 0. Sorry, the cotangent's at 0. In this case, it's going to be up 1. So I'm going to call this 1. Actually, I want to do, looking at the 1/3, I want to go up 3 tick marks to call that 1. Alright, so this is where the cotangent wave will be. And that's the same thing in between all of these asymptotes. That's where the function's going to be in its middle. Okay, normally from the middle halfway to the asymptote to the left, it's up 1. This one's going to be up 1/3. So left, halfway to the asymptote, it's going to be up 1/3, which is just 1 tick mark because I put 1 up 3 tick marks. And then down, so up and down, up and down. We can now sketch 1 cycle of the cotangent. That would be 1 cycle. I have enough asymptotes to actually sketch 3 cycles. So I can finish these up. If you ever needed to locate this point, for example, this point right there, see, pi8, 2 pi8, 3 pi8, 4 pi8, 5 pi8 is the x value, and I just had to add tick marks. This is why I'm so careful about setting up the tick marks. It makes it really easy to do this. And then it's up. This is 1. Each of these is a third. It's up 2/3. So if you needed to find the coordinates of those points, since we were so careful with our tick marks, we could. The last thing I want to discuss, let's see, the frequency. This frequency is always 1 over the period. So in this case, the period being pi halves, 1 over pi halves is 2 over pi. So that might be something they ask about, the frequency. They can also ask about the asymptotes. And this x equals, pick your first asymptote. I have it pi8, 2 pi8, so that's pi4ths. You can pick any asymptote you want. And then how far to the next one is 4 tick marks. Each tick mark's pi8s. 4 times that would be pi halves. Happens to be the period. You do pi halves times k, where k is an integer, and you have generated the first one plus an infinite number more. So you're just saying start at this one, and then add or subtract. The k is an integer, so it allows you to go backwards 4 tick marks, and you'll find the next one, and the next one, and the next one. They could also ask for the domain. And that's just the set of all x's such that x is not equal to all the stuff you just wrote. 2k pi, sometimes the k is in the numerator instead of on the right. Okay. This represents most of what I could think of they could ask about a cotangent. I hope this helps.